Students, welcome to the fourth session of complex integration. As in this session, I would like to discuss one important theorem, that is Cauchy's theorem. Okay, so here, um, before that, before going to that Cauchy's theorem, so you should know, here we prove this theorem by using Green's theorem, which you have studied in integral theorems. Okay, so we are taking the help of by using the help of Green's theorem, we prove the Cauchy's integral theorem. Yes, I just remind the statement of the Green's theorem here. Green's theorem in the plane, as it states that Green's theorem states that if P and Q be two continuous functions having first order derivatives in a region D, so they are differentiable in the region D, consisting of points within and on a simple closed contour C. So the points are in closed contour C of the domain D. So then integration of P dx plus Q dy over C, that is the line integral. Integration of P dx plus Q dy over C is the same as double integration of del Q by del X. So that is the partial differentiation of Q with respect to X minus del P by del Y, partial differentiation of P with respect to Y. So into dx dy over the region D, over the region D. So that that is the relation. Uh, so pdx plus q dy can be, so that value is same as del q by del x minus del p by del y into dx dy when you are evaluating in the plane. Okay. So now by using this Green's theorem, we can easily prove the Cauchy's integral theorem. So let us state what that Cauchy's integral theorem states. So Cauchy's integral theorem states that if f of z is an analytic function and f dash of z is continuous, it is a continuous function at each point within and on a closed curve C, within and on a closed curve C, then integration of f of z dz over C is equal to 0. So actually what it states, if f of z is an analytic function and its derivative, that is f dash of z, is continuous at every points in the closed curve, at every point in the closed curve C, so then the integration of f of z with respect to z over C is always 0. As to prove this theorem, Cauchy's integral theorem, okay, so first you take uh, that function f of z. Okay, I'm just going to prove this theorem. Yes, so what is f of z? F of z is the function of z. Z is a complex number, that is we can write that z is x plus iy. Similarly, you can write f of z is it is a function of u and v. So u of xy plus I into v of xy. Okay, now you writing, you take that f of z is equal to, it is a function of xy plus I into v of xy, plus I into v of xy, and note that what is that, z is x plus iy, so dz can be written as dx plus I dy, dx plus I dy. So I am writing this because I need to find f of z into dz. F of z into dz ಬೇಕು ನನಗೆ. F of z into dz ಬೇಕು ಅಂದ್ರೆ we have to consider f of z and dz first. Therefore, f of z into dz can be written as f of z into dz is equal to, in simple format I write f of z, that is u plus iv into dz is dx plus I dy. You multiply these two, it is u into dx plus I u into dy. Next I into this plus I v into dx plus I into I square v into dy. As all of you know that I square is minus 1. So you can write it as u dx minus v dy. U dx minus v dy plus I into, you take I is a common factor, I into u dy plus u dy plus v dx. Okay. So then now, so after this, you simplifying this as, okay, after finding f of z into dz, you take its integration. Therefore, integration of, sorry, integration of f of z into dz over c is equal to integration over c, it is u dx minus v dy plus I into u dy plus v dx. Okay, so this is the integration of f of z into dz. We can also write this in the form. So which is equal to, its simplification gives that, which is equal to integration over c. So I just wanted to take dx is common factor. Okay, so then it is u dx. This is plus iv dx. So take it is u plus iv into dx. From these two, you take dy is a common factor, or you can take I dy is a common factor, plus just write it is plus I into integration over c, and you just write it is the u, and this minus 1 can be written as I square plus I square. This minus can be written as plus I square. Okay, if you take I is a common factor, remaining is plus I into v plus iv plus iv into dy. Okay, so then, so next step you write, here you use Green's theorem. So that is so I'm using Green's theorem here. So by using Green's theorem, so what it states, Green's theorem, that is integration of p dx plus q dy over c is equal to double integration over d. So this is del q by del x minus del p by del y minus del p by del y into dx dy. This is Green's theorem. Okay, I'm using the same Green's theorem here. Therefore, if you use this Green's theorem, now we have from, you take this is equation 1. So integration of f of z dz over c. You take this is 1. Okay, you take this is 1. Okay, now we have from equation 1, so that I am writing this integral 2 times here. Okay, so just take this pdx plus, this is the pdx plus, and this is the q dy. It is a, in place of q, take this I into u plus iv, I into u plus iv. So if you use this here, we use this Green's theorem. Now we have integration of f of z dz over c is equal to double integration over d, double integration over d, del q by del x. What is in place of q? You see, this is like this, p dx plus q dy. So in place of p we have u plus iv. In place of q we have I into u plus iv. Okay. So it is del by del x of q. Q is I into u plus iv. Okay. Minus del p by del y. Del p by del y of p. P is u plus iv. U plus iv closes this into dx dy. This into dx dy. So which is equal to double integration over d. As you keep this I outside, I into, this is I into del u by del x plus I into I is I square into del v by del x minus del u by del y plus into minus I into del v by del y. So this into dx dy. This into dx dy. So which is equal to double integration over d. Double integration over d. Here you write the real terms. So that is, so I square is minus 1. Take minus 1 is a common factor and write minus of del v by del x. You see, I think we have one I outside. Okay, we written this, no problem. So minus of del v by del x plus del u by del y. Next, take I is a common factor plus I into del u by del x minus del v by del y. Okay. So now this into dx dy. This into dx dy. Here we use the CR equations, that is Cauchy-Riemann equations. So by using Cauchy-Riemann equations here, I think it is visible now. Yeah. So by using CR equations, so what are the CR equations? If f of z is analytic, then del u by del x, if f of z can be written as u plus iv, so then del u by del x is equal to del v by del y and del v by del x is equal to minus del u by del y. These are the CR equations. So using these equations in equation 2, if we use these equations here, then integration of f of z dz over c is equal to double integration over d. So this into minus of, as you write del v by del x, and del u by del y can be written as minus del v by del x. Del u by del y can be written as minus del v by del x. So write it is minus del v by del x plus I into del u by del x can be written as del v by del y minus del v by del y, you write as it is del by del y. Close this into dx dy. Here del v by del x cancel with minus del v by del x. Del v by del y cancel with minus del v by del y. So integration of f of z dz over c is equal to that right hand side is completely 0. Okay. So just to remind this theorem once again, just remind this one. Is the Cauchy's integral theorem states that if f of z is any analytic function and f dash of z is continuous at each and every point in the closed contour C, so then integration of f of z dz over C is equal to 0. To prove this, first you write f of z, the analytic function f of z. So f of z standard notation is u plus iv. So that is u of xy plus I into v of xy. And you note that z is x plus iy. So you can write dz is dx plus I dy. I am writing it because I wanted to find f of z into dz first. Okay, what is f of z? It is u plus iv. And what is dz? Dx plus I dy. If you go on simplifying this, it assumes this form u dx minus v dy plus I into u dy plus v dx. Okay, after that, you substitute the same in integration of f of z dz. So integration of u dx minus v dy plus I into u dy plus v dx over c. So after this you take dx as a common factor, or otherwise you take dx as a common factor here itself, no problem. So then if you take dx as a common factor, then it is u plus iv into dx plus I into u plus iv into dy. So now I am using the Green's theorem. It is like this: integration of p dx plus q dy. So in place of p we have u plus iv. In place of q we have I into u plus iv. So you use the same here, del q by del x. So in place of q it is I into u plus iv del by del x of I into u plus iv minus del by del y of p, that p is u plus iv into dx dy. Okay, go on simplifying this. Keep this I as it is. Del u by del x plus I into I is I square. Differentiation of u with respect to x is del v by del x, that is a partial differentiation, minus del u by del x del y. So minus I into del v by del y into dx dy. Okay. After this you separate real and imaginary part. Then it is del v by del x plus del u by del y plus I into del u by del x minus del u by del y. Since f of z is analytic function, so it satisfies the Cauchy-Riemann equations. CR equations satisfy ಮಾಡುತ್ತೆ. So that CR equations is del u by del x is del v by del y. That is, in place of del u by del x, we can take del v by del y, or del v by del x is equal to minus del u by del y. I'm using that CR equations here. So then all the terms gets cancelled in right hand side. So that right hand side becomes 0. So this is the Cauchy's integral theorem. Okay, this is the Cauchy's integral theorem. Hope you understand this. Next, I wanted to discuss the consequence of Cauchy's theorem, that is Cauchy's integral theorem. So Cauchy's theorem states that if you take a closed contour C and when f of z, that function is analytic, and f dash of z is continuous inside that contour C, then if you take the integration of f of z dz, integration of f of z over C, then definitely it gives 0. By using that Cauchy's integral theorem, we can prove some of the consequences. So what that consequences are? The first one is the line integral of a function f of z. You take the line integral. The line integral of f of z, which is analytic in the domain D. Okay, it is analytic in the domain D. And z is equal to and z is equal to b are 2 points in D. So you take any 2 points, A and B in D. So then integration of f of z dz from A to B, with the limits from A to B, is always independent of the path joining the points A and B. As I discussed some problems, when we are changing the path of the integration, so for sometimes we get different answers. But you take any path between 2 points. So z ಅಲ್ಲಿ ನೀವು ಯಾವುದೇ ಎರಡು ಪಾಯಿಂಟ್ಸ್ ತಗೊಂಡ್ರೆ, if you take any 2 points, okay, so suppose p and q are 2 points. If you wanted to take the line integral along this pq, so you may take the straight line from a p to q. You may take this type of curve from p to q. You may take this curve from p to q. Okay, if you take integration along different paths, so in that time we get different answers. But in some of the in some situations like this, that is when f of z is analytic in D, when f of z is analytic in D, so when f of z is analytic, so then integration of f of z from p to q does not depends on the path. It is independent of the path. Path ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ. ನೀವು ಯಾವ ಪಾತ್ ಅಲ್ಲಾದ್ರೂ ತಗೊಳ್ಳಿ, ಸೇಮ್ ಆನ್ಸರ್ಸ್ ಬರುತ್ತೆ. ಸೇಮ್, we get the same answers, different paths. So it is independent of the path only when f of z is analytic in D. Yes, we need to prove this consequence. To prove this, we are using the Cauchy's theorem again. Okay, Cauchy's theorem use ಮಾಡಿಕೊಂಡು, so we are going to prove the consequence. Yes, to prove this, so let us take 2 points. As they are given that z is equal to a and z is equal to b are 2 points. Okay, you take, this is the point z is equal to a, and you take another point z is equal to b. I denote this point as a, capital A, and I am denoting this point is b. You take a path, you take one path from A to B. So this is one direction, this path in one direction from A to B. Okay, and you take this arc is C1. Okay, so it moves from the point B. Take another path from B to A or A to B like this. Okay, you take this the point B, and this moves from Q. This moves from Q, and you take, this is another arc, so that is C2, another curve C2. So just write the same words here. Let z is equal to A and z is equal to B represent the points, represent the points A and B in the region R or in the domain D. Okay, in the domain D, let C1 be the arc joining A and B, the points A and B, and passing through the point P. And C2 be another curve. C2 be another curve joining A and B, passing through the point Q. Yes, it is passing through the point Q. So that is, so you take arc APB. So this is the arc APB. Arc APB is C1, and another one is arc AQB. This is arc AQB. Arc AQB, you take it is C2. So now we have one complete closed curve. So that is A, P, B, Q, A. So it is a complete closed curve. Therefore, the curve APB QA, APB QA is a closed contour, contour in the domain D. Okay, it is a closed contour in D. It is closed contour in D. So therefore, now we can apply the Cauchy's integral theorem. Therefore, by Cauchy's integral theorem, Cauchy's integral theorem, integration of f of z dz over this closed curve. What is that closed curve is? This is the closed curve APBQA. So Cauchy's integral theorem is if we consider if you take the integration of f of z dz over a closed contour C and f of z is analytic in that time, so its integration is equal to 0 ಅಂತ ಹೇಳಿದ್ರೆ. So if you take this closed contour APBQA, okay, you take it as APBQA, it is APBQA is equal to 0. Sorry, may not. Okay, APBQA is equal to 0. So you can split this curve, okay, in line integral ಅಲ್ಲಿ ಇಷ್ಟನ್ನು curve ನೀವು first you can consider along C1, next you can consider along C2. First you can take APB and next you can take from BQA. So like that you can split. So if split like that, which implies that integration of f of z dz over APB plus integration of f of z dz over BQA is equal to 0 by using Cauchy's integral theorem. Okay. So now, which implies that integration of f of z dz over APB. APB means that is the curve, that is the arc. APB means that is the arc C1. So you can take C1 in place of this, you can take C1. So C1 plus if you wanted to change the direction, because you see, if you consider C2 means it is along AQB. So here the curve is along BQA. If you wanted to change the direction, that is from AQB ತಗೋಬೇಕು ಅಂದ್ರೆ you have to put minus sign here. So if you put minus sign here, okay, so that is ಇಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಮಾಡಬೇಕಂದ್ರೆ ಮೈನಸ್ ಹಾಕಬೇಕು. Take minus sign and instead of BQA you take AQB. I am changing the direction, so for that I just put the negative sign here. Okay, so integration of f of z dz over C1 minus integration of f of z dz over C2 is equal to 0, because arc AQB can be written as C2. Arc AQB can be written as C2. Now we have that integration of f of z dz over C1 is equal to integration of f of z over C2 So what it indicates or what it shows, if you take the integration of f of z along C1, so the same as integration of f of z along C2. So this is C2. If you take its integration of f of z over with any path between A and B, so in both the cases, we consider arbitrary paths. ಯಾವುದೋ ಒಂದು ಎರಡು path ತಗೊಂಡ್ವಿ. So in both we show that the integration of f of z dz over that paths are same. So it is possible only when f of z is an analytic function. Okay. In other cases, it is not possible. In other cases, it is not possible. If f of z is analytic function, so the integration, line integration between 2 points, it does not depends on the path. Okay. So it depends only on the points, the end points. Okay. So this is one of the consequence of Cauchy's theorem, and one more consequence is there here. So that is so f of z be analytic in a region or between two closed contours C1 and C2. So then integration of f of z dz over C1 is equal to integration of f of z over C2. What it states, f of z be analytic in region R between two closed contours C1 and C2. So C1 and C2 are two closed contours. C1 and C2 are two closed contours. So if f of z is analytic function in the region R, if we take two closed contours, the integration of f of z dz over C1 is same as the integration of f of z dz over C2. So to prove this, first draw that closed contours C1 and C2. C1 and C2 are closed contours, so maybe like this. Okay, just take one closed curve like this. Okay, and you take one more curve, closed curve, or you take it is C1. Take one more curve, and you take this is C2. Okay, so this is the region R. Okay, R is the region between C1 and C2. R is the region between C1 and C2. Okay, yes. Just write some words regarding this. So let the closed contours, let the closed contours, contours C1 and C2 be such that R is the region, between C1 and C2. R is the region between C1 and C2 where the contours C1 and C2 both are in the positive direction. Both are in the positive directions. Okay, to this one, I just wanted to introduce a cut. I just take a straight line here. Okay, and you mark these points as A and B. Mark these points as A and B. Introduce a cut. Introduce a cut AB from the point A on where A is on C2 to the point B on C1. B on C1. So now, then the region R between C2 and C1 is a closed contour. Yes, when we are introducing this cut, okay, if we cut this region here, so then we can you cut it and you take its parts, so that may be looking like this. ಅದನ್ನ cut ಮಾಡ್ಬಿಟ್ಟು ನಾವು ಈಗ ಇಟ್ಕೊಂಡ್ರೆ so maybe ನಮ್ಗೆ ಈ ತರ ಕಾಣಿಸ್ಬೋದು ಅದು. So it may be like this. Okay, so this is the point A and this is the point B. In another edge also that same points, ಯಾಕಂದ್ರೆ ಇದೆ ಅಲ್ಲ, ಇದು ಎ ಆಗಿದ್ರೆ ಈ ಕಡೆ ಸೈಡ್ ಇಂದನೂ ಎ ಬಿನೇ ಆಗಿರುತ್ತೆ. ಓಕೆ, and so this is the inside region, this is the outside region. So ಇದು C2 ಆಗಿರುತ್ತೆ ಇದು. So you take it is C. Okay, so if you take one direction, maybe like this. Yes, so now closed contour. So given line segment, first one, line segment AB, line segment AB. Okay students, if you introduce the cut AB here, okay, you get this type of structure. So it is a closed contour. ಇದು ಕ್ಲೋಸ್ಡ್ ಕಾಂಟೂರ್ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಸ್ಟಾರ್ಟ್ಸ್ ಫ್ರಮ್ ಎ, ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಳ್ತೀನಿ ನಾನು. ಸೊ ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದು, ಐ ಥಿಂಕ್ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಅಬ್ಸರ್ವ್ ಫ್ರಮ್ ದಿಸ್ ಕರ್ಸರ್. ಸೊ ಐ ಸ್ಟಾರ್ಟ್ಸ್ ಫ್ರಮ್ ಎ ಇಂದ ಬಿಗೆ ಬರ್ತೇನೆ. ಓಕೆ, ಸೊ ಆಫ್ಟರ್ ದಿಸ್ ಫ್ರಮ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಬಿ ಇಂದ ಅಲಾಂಗ್ C1, that is the positive direction of C1. So again I come back to B. Okay, I start at this point and then move to B along C1. So it moves from B to B. You can write it is C1. Okay, so and this is C2. Okay, so ಇಲ್ಲಿ C1 ಇಂದ okay ಇಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದೆ, ಇಲ್ಲಿಗೆ ಬಂದೆ. So and after that I come back to this point B. So that is along C1. After come back to B, again I have to move from B to A. That is the line segment B to A. So after going back to A, point A, so again from here you have to move to this point A. From A to A ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಮೂವ್ ಆದ್ಮೇಲೆ ಮತ್ತೆ ಹೇಗೆ ಈ ಡೈರೆಕ್ಷನ್ ಬರಬೇಕಾಗುತ್ತೆ. ಅಂಡ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಈಸ್ ಆಪೋಸಿಟ್ ಟು C2. So that is or in the direction of minus it you can take. Okay, so that same thing I am written here along line segment AB, along AB, after that B to B, arc B to B along C1, after that line segment B to A, after that B to A, and then along AA. So along AA ಮತ್ತೆ ಈ direction starts from here, then here, then move to this point, then A to A. So this is the direction opposite to C2, positive direction of C2. So or in the direction of minus C2 you can take. Okay, so now we have a one closed contour, that is ABBAA. ABBAA. Okay, so if we take integration of f of z dz over that, so that is the by using Cauchy's integral formula here. So by using Cauchy's integral formula, by using Cauchy's integral, sorry, not formula, it is a theorem. Formula ಬೇರೆ ಇದೆ ನಮ್ಮದು, theorem. Okay, so that is integration of f of z dz from BBAA again b. Okay, b b a b in is equal to 0 according to Cauchy's integral theorem. The integral of f of z over this region is 0 because f of z is analytic and BBAAB is a closed contour, so its integration is 0. Now you split this region as integration of f of z dz from b to b. You can take it as actually we start from a. Okay, no problem. B to b, or otherwise you take it as a b because we start from the line segment AB, so you write it is ABB. You write it is ABB A B B A B B A B. Okay, so now you take this is integration of f of z dz along the line segment AB plus integration of f of z dz along the curve BB plus integration of f of z dz. So after BB it is BA, line segment BA plus integration of f of z dz. So after BA it is from AA, which is equal to 0. So this is an arc and BB is an arc. Okay, and AB is a straight line, BA is a straight line. So because okay, now integration of f of z dz over AB plus integration of f of z dz along BB is the closed contour C1 plus, so if you wanted to change its direction BA as AB, so then you write negative sign integration of f of z dz and you write it is AB plus integration of f of z dz, so that AA is nothing but minus C2, which is equal to 0. So these two terms cancels. Okay, because this is AB along this is along AB, so this has the positive sign, this is negative sign, you can cancel that too. So integration of f of z dz over C1. So in negative direction is like change ಮಾಡಬೇಕಂದ್ರೆ we have to put negative sign here, minus integration of f of z dz over C2 is equal to 0. Okay, so now integration of f of z dz over C1 is equal to integration of f of z dz over C2. So that means if we take so many closed contours, f of z is analytic in the region, or in that time if we take the integration of f of z dz over C1 is same as the integration of f of z dz over C2. So this is the another consequence of Cauchy's. Okay, so the first consequence is that usually consequences are not asked in examinations, very rarely asked in examinations, ತುಂಬಾ ಕಡಿಮೆ ಕೇಳೋದು. But this theorem is very important, that is Cauchy's integral theorem, ತುಂಬಾ important ಇರುತ್ತೆ ಇದು. So many times asked in examination, so concentrate on this. So next class I just discussed that Cauchy's integral formula. So that is also very important concept, Cauchy's integral formula. So after that I discuss the problems on Cauchy's integral formula. So thank you, take care.